I'm seeing quite a lot of thumbs down. All right. So it might be a little bit difficult for you to kind of get where we're going with what's happening on the screen. If you haven't quite done the back work that we've done with triangles, with congruency, with similarity, everything along those lines is very important. However, I'm hoping you guys will stay with us because everything that I'm going to be speaking about will somehow come from grade 9 maths to an extent. So I'm going to be testing how much of your grade 9 maths you actually remember on geometry. Hello, Kama, our resident fly diva. How are you doing today?
Hi, girl. I'm good. Honestly. Yeah. So like on the Euclid part, like
yes, ma'am.
We haven't done it, but I think we're going to be starting it this week because like we just wrote our trig test, which was just like finalizing that we're basically done with trig for the the term, hopefully.
Excellent. All right.
So
I'll tell you one or two things will probably happen.
Okay.
I'm anticipating you either do functions and then come back to Euclid and analytical, or they'll do Euclidean and then analytical and then functions. So I'm not 100% sure where your school will go, but we'll see how they choose to do that.
There's no
we,
way,
however, are going to be, we're going to be doing this, and then we're doing analytical and then functions. So I'm sorry if the order is a little weird. Okay.
No, don't worry about it. Yeah, Sana, there's no ways. You don't understand the stress. I stayed up all night last night. Well, not all night, because like I decided to choose peace and I decided to sleep. But like I was studying for maths, and I was like, you know what?
And how did it go?
Yeah, I didn't finish it. I didn't finish it.
Oh no! Let's cross fingers. What you did right is actually on point, because then your marks. Yeah.
And all right, may not even be for marks. So I'm just praying for that end.
Okay. All right. We're going to, woosah and continue with Euclid, and hopefully your marks will catch up. Hey.
Yeah. Dear God.
They'll catch up. Come on, don't stress. Okay. Yo, that was like you only started linear graphs. I will. Akumila says, should we write this down? No, we're not writing this down. I'm just reminding you guys of quadrilaterals as we go along. All right, so we're going to be looking at quadrilaterals very quickly. So we had actually looked at the properties of quadrilaterals and used them to prove that quadrilaterals are actual quadrilaterals. So let's see if everything that's happening now can be joined together to kind of make sense. So remember, guys, we're looking at the properties of these, and the question that I've got today for a proof is a parallelogram. That's what we're going to be proving. We're going to be proving that ABCD is a parallelogram. Now, we've been given a certain amount of information, right? We've been given a certain amount of information, and we need to make sure that the information matches up with what we have. And then there was that nice long word, that nice long acronym that we learned the other day called cpctc, which stands for corresponding properties of congruent triangles are congruent. And if you remember what a congruent triangle is, if I have two triangles and they have the same corresponding sides, and they have 1, 2, 3, 1, 2, 3, and they have the same angles. Okay. Right. I know, Unati, they really do make it hard. Right. If I have two triangles that look exactly the same, if I can prove that they're congruent without a lot of the other stuff. So let's say, for instance, I use these two rules. Hey, look at teacher Coco now. Coco, come on, get it together. All right, I'm going to leave it. If I can use this rule and that one, if I can use SAS to prove that this triangle is congruent, then automatically this side and this side must be equal. this angle and this angle must be equal, and this angle and this angle must be equal because they're congruent. So if I can use the properties of some of the triangles to prove that they're congruent, automatically the other sides are congruent. We don't even have to go into how to prove that. That is the automatic. And that's what cpctc means. If I prove that this side is correspondent to that side, and my angle is correspondent to that angle, this side is correspondent to that side, the other sides automatically come into play. All right, and that's how we can use the idea of cpctc. Now, this particular question says that AE is a median to triangle ABD. So what they're actually saying to us is that this line AE is a median to triangle ABD. So that means that it cuts these two parts equally because it's a median. Okay. And Amohelang is like, ma'am, can you please explain congruent? I can't remember. Yo, my sweetie, we are on lesson 5 of 6. We go into congruency with so deep in lesson 1 and 2 that I think you might have to go and watch those. And for those of you who are asking, what does congruent mean again? I want some of my veterans to drop their answers in the chat for Amohelang and Junior and remind them, what do we know about congruent triangles, guys? What do we know about two triangles that are congruent? Pop it in the chat. Let's see how much you guys actually remember. Same sides. That's it. Moteo, Mawande, you're onto something, but Moteo's is being a lot more broad, like a lot more. Nkanka, remember, you can't just say the same. Okay. You can't just say the same. We need to say that they are exactly the same. So one of the sides is equal to another side in the triangle. The angle on that side is equal to the angle on the other triangle. Everything about them needs to be exactly 100% the same. Someone who said this? Who said this? Remufilo's like, they are in agreement. Yes. They are in agreement. That's it. Who yes, Nico says same shape, same size, 100%. Atumile, all the angles are equal, but also all the sides need to be equal. The corresponding sides also need to be equal. Okay, that's it, Nicole. That's it. And Sipa is just giving us examples of the different ways that we can prove congruency. SAS, SSS, ASA, AAS. All of those are 100% important. All right. Somebody said, please tell us again, what does cpctc stand for? I'm going to try and write it out in my best handwriting because these days my handwriting is not the one. Okay, so it stands for corresponding properties. No worries. Hello, Palisa. Properties of congruent triangles are congruent. Okay, cool. That's what cpctc stands for. Okay. All right. So when they say to us here, they're giving us the information that line AE is a median to triangle ABD. What they're actually saying is that AE, the line AE, as it goes through here, it cuts the line BD right down the middle. That automatically tells us that BE and ED are going to be equal. Yes, Amohalang, I forgot RHF. Yes, RHS also. Okay, then it says that E is the midpoint of line AC. So E, this should be over here, this AC just moved out of the way. E is also a midpoint of line AC. So I'm lying. That means AE is equal to EC. That's what they're telling us here. All right, so we can use the properties that we've been given here to prove that, excuse me, to prove that that ABCD is a parallelogram, right? Can anybody, any brave soul, put their hand up and tell me, what kind of properties of a parallelogram do we want to prove here? Hello, Olwetu, welcome, welcome. Yes, absolutely, Tumelo, you should. Moteo, hello, my sweetie. How are you doing?
Hi, Mom.
Hello, my sweetie. All right, give me one thing that we could possibly use to prove that this is a parallelogram. What would we need to prove?
Angles opposite equal side.
Okay, we can say angle opposite equals side. Yes, so we can prove that this is an isosceles, but that's not gonna work, Mateo, because our parallelogram is at an angle. So we're not gonna be able to prove that this angle and this angle are equal.
Oh,
Right. So I think your wording is a little weird, but if we think of all the properties of a parallelogram, what do we know about? It's in the name, by the way, it's in the name.
Oh, the sides must be parallel. The angles
Beautiful.
and the sides must be parallel.
Good. So we know that BC must be parallel to AD, and we know that AB must be parallel to CD. Yes?
Yes.
Anything else?
Diagonals bisect.
Good, the diagonals bisect. And we know that they do because they've given us the property of our bisecting diagonals. Okay, cool. Let me see if Mawande has something else for us. Okay. Mawande, got anything else that we could use to prove that they are congruent, that our thing is a parallelogram? Anything else?
Opposite sides are equal.
Good, opposite sides are equal. Yeah, okay, opposite angles. So we can get C and A should be equal, and B and D should be equal. Also, do you agree with me? BC should be equal to AD?
Yes.
Any other,
yeah.
anything else? Anything else? Any other two sides need to be equal? AB and?
BC, BA and
good. AB and DC also need to be equal. All right, excellent, well done. All right, so that's some of the things that we're going to have to look at proving in order to look at this. What in the world did Mem do now? Okay, there we go. To prove that our parallelogram is in fact a parallelogram. All right, so here's what I want us to do. I want us to look at two different angles here. I want us to look at two different angles, or triangles rather. We're going to look at two different triangles. I'm first going to look at the triangle ABE, close. And I'm going to look at the triangle, where did I start? At A, CDE, close triangle. Now, remember, guys, the order in which we write them is very important. So I'm going to go in triangle. I started at A, so I'm going to go ABE and triangle CDE. Okay, I want to prove that these two triangles are congruent. Anybody got any statement that that I can say to prove that these things are congruent? Remember, I need 3 reasons. And Unati, absolutely the order matters. The order is the most important thing. The order is the most important thing. And Puseleto E is not common. It's not. Ashlon, what do you think? Ooh, Ashlon is not unmuting. Oh no, Zama, what do you say? Oh, there we go. Hi.
Hi, ma'am.
How are you doing, my sweetie?
I'm good, and you?
Good, thank you. All right, what can we say about the order in which we see these triangles?
Ma'am, this one I don't know.
Okay. Is that what you wanted to ask me?
No, ma'am. I wanted to answer the previous one.
Oh, okay, I see, my sweetie. All right, I see. Okay, let me give you a hint. What do these 3 lines tell me? 1, 2, 3, 1, 2, 3. What do they tell me about this side and that side? That they are?
AE and EC is equal.
Good. So I can write that as one of my reasons. I can go AE is equal to EC, right? And our reason is going to be that they've given it to us over here. Diagonals bisect diagonals of AC, oh, midpoint, sorry, it's midpoint because they've told us that E is the midpoint. Okay, then we can say E is midpoint of AC. Okay. Okay, thank you, Ashlon. I think that was a very helpful one. Does anybody have any other one? Let's see. Zama, can you see another one on the screen? Hi, Zama.
Yes, I think I can see one.
Yes, which
where
one?
I think it's B and D. They are common.
Good. They're not common. Look, these two lines tell me that from B to E, that is the same length as E2.
Yes.
Good. So we need to write it that way. Okay, so what are we going to say? I'm going to go BE is equal to?
BE is equals to C. Oh, no, B equals to D. No, it's equal to DE, yes.
Yes, to DE. Good. It's equal to DE or ED, whichever one is good. And the reason is that?
They bisect.
Good. So we can say that they bisect, but we need to use the information they've given us. They told us that AE is a medium.
AE is a medium.
Good. So we need to use that information. AE is medium.
The medium.
Good. Median
Yes.
of line BD. All right, that's the information they've given us. All right, excellent stuff. Well done, Zama. Nicole, you look a little confused, and I see Gutle saying given. I will accept given, yes. Okay, we cannot speak about anything being parallel, guys, because they haven't told us that anything is parallel. Okay. Okay, I'm seeing this issue that's going on right now at the moment. I'm seeing a lot of people getting kicked out, and Mateo says, what's a median? Median means middle. Okay. All right, I'm gonna have to investigate. I'm gonna quickly ask on the group, on our IT group, just to make sure that nobody's getting kicked out and that we're not having these kinds of issues. All right. Give me 1 second, guys. 1 second. Let me do that. Okay. Okay, I just want to make sure that you guys get the relevant help. Okay. All right, there we go. Okay, so I've messaged people. Hopefully they'll be able to help us solve that. Dumelo, we cannot say that BC is parallel to AD. They haven't given us that information. Okay, I need one more. Haley says, are we allowed to use fun? No, Haley, we cannot, because they haven't told us that any lines are parallel. Remifilwe, do you notice anything about E? Look at E in the middle.
Okay, ma'am.
I'll give you a hint. It has something to do with these two lines like this and the angles around there.
E bisects. Is it
that's
correct?
not going to help us. Okay, I'll tell you, these are converse lines because they go right through each other. Right.
Ma'am, may I please ask a question?
Yes.
Would you say that AB and CD are equal? AB is equal to CD, and then the reason might be, okay.
Okay, and the reason I'm stopping you there is because they haven't given us that information. The two answers that I have here at the top, it's information they've already given us. Do you see that? My reasoning is coming from here. Okay.
Oh, okay, I see that, ma'am.
So I can't then just say AB is equal to CD. They haven't given me that information. Okay.
Yes, ma'am.
All right. Okay, I'm going to ask you guys. Hi, Nolwazi. I see you've got a question as well.
Hi, ma'am.
Hello, my sweetie.
Ma'am, I was asking if does this have anything to do with straight lines?
Yes, straight lines. But let me ask you, Nolwazi, what do we know about this angle and this angle? Beat me to it.
They are vertical opposite.
Yes, which means that they're
Always
equal.
equal.
That's the thing that I'm looking for. Do you see how they're in the two triangles that we are comparing?
Yes, ma'am.
Yes, good. So I can say angle BEA, and I'm going to put my little hat on E, is equal to the other side, which would be angle DEC.
C.
Right. What's my reason, Nolwazi?
Vertical opposite are vertical op angles equal.
Good. Vert op angles are equal.
So,
All right,
ma'am,
excellent.
I wanted to ask, if we were given
Yes.
the value of E, would we have to calculate the angles in a straight line?
Well, yes, but in this case, if they had given you, even if they'd given you this angle, it would have helped you because you would have known this angle. Okay. And if they gave you this angle, it would have helped you because you would know this angle. And then you can prove congruency from there. Okay.
Oh, okay, ma'am. Thank you.
All right. Sure. Excellent. Unati says, ma'am, would you lose marks if your order was incorrect? No, it makes no difference, because now we can actually say that our triangles are congruent. Therefore, triangle ABE is congruent to triangle CDE. Now, my reasoning behind this, we need to now look. I have got a side and an angle in between them, a side and an angle in between. Can anybody tell me what is my reason here? What is my reason for congruence? That's it, Nicole. Excellent. That's it. Yes, Viwe. It's side, angle, side. And we'll remember that because the angle is in between our two sides. Side, angle, side. Now, I want you guys to look at the next two triangles that we're going to look at. I'm going to be looking at triangles. So I'm going to go in triangle. I need to map this out correctly so I don't make a mistake. In triangle BEC and triangle, I started at B, so DEA. There we go. All right, I need 3 reasons that will prove that these things are congruent. Okay. Yes, Nkuri. Nkuriso, I think it's Nkuriso. I hope I said that correctly. I see your hand is up, my sweetie. Hello.
Yes, ma'am. I wanted to answer the previous question.
Oh, the previous question. Okay, can you answer this one for me, though? Let's have a look. I don't think it's that difficult. Okay, I need you to tell me. Remember, here's my 2 triangles, BEC, close triangle, and DEA, close triangle. Okay, can you tell me anything about these 2 triangles?
AE is equals to CE.
Beautiful, that's it. AE is equal to EC or CE, doesn't matter. And this information is given to us, right? We're going to take it from before. Anything else?
And BE is equals to DE.
Good. BE is equal to ED. And it's also given information. All right. It's given. Good. I need one more reason, Kuriso. One more reason.
I think it's A angle E is equals, sorry. A angle ED is equals to B angle EC. It's
good.
Vertical
That's
opposite.
it. That's it. Good. And the reason?
It's vertical opposite.
Beautiful. That's exactly what I wanted to hear. DEC. And their vert op angles. Beautifully done. Very beautifully done. Okay. Now I can say that triangle BEC is congruent to triangle DEA. So you're a whole legend. Okay, and my reason again, guys, is going to be side, angle, side. Now, I want you guys to note that because we've proven at this point, we have proven that we've proven that these two sides are equal and they have an angle in common and that they are congruent. These two, like BEC is congruent to DEA, and we've proven that BEA is congruent to DEC. Then that automatically tells us that side AD is equal to which side, guys? Which side is AD equal to? To BC. Good, Kushe. AD is equal to BC. What is my reason? Why can we make that conclusion? Why can we say that AD is equal to BC? Yes, Tato.
Hi, ma'am.
Hello, my sweetie.
Ma'am, I think it's congruent.
Yes, but there's that nice long word that I had you guys learn at the very beginning. Do you remember?
No, ma'am, I just joined recently.
Oh, did you just join? Okay, all right. Okay. Does anybody remember that long word and everybody even said, ma'am, what does this thing mean? Yes, Buntle, you're on the right track. Okay. Not because they are parallel. Zama, do you remember what that word was?
Yes.
Oh, no, don't mute. Come back. Yes.
Yes, ma'am, I do. It's corresponding property of congruent triangles are congruent.
Beautiful. Yes, that's what I was looking for.
Yes, ma'am.
CPCTC. Okay, now that we know that CPCTC applies, which other sides do you think are going to be equal to each other? Oh, you're muted again?
Oh.
Hi, Bozama. Oh no. Okay, Kama, help us out here. Because Zama keeps getting unmuted.
Girl. It's not make sure right now.
Okay, hold on. Hold on, my sweetie. Have a look. Have a look. We've proven that because these two triangles, this one and this one are congruent, we know that AD and C will be equal. We've also proven that this one and this one are congruent. So which other two sides are going to be equal?
I'm guessing AB and DC.
Yes, don't guess, it's correct. Yes, AB and CD are correct. Yes. And our reason is going to be AB is equal to CD because of?
cpctc.
That's it, corresponding properties of congruent triangles are congruent.
Yo, you don't understand. I just heard a really long word and I was like, what the heck is going on?
Well, it was the correct one. It was. Okay, excellent. Okay. But what does that tell us about the angles as well? Amma, what are we going to know about the angles now?
That they're equal?
Yes, 100%. That means angle B will be equal to angle D. And angle A, this angle over here will be equal to angle
C.
Exactly. They are equal because the two triangles are congruent. And that's why we use cpctc. Okay.
Oh, wow. Tense.
It's all good, my sweetie. Trust me. Trust me. We're on the right. All right.
Thank you, ma'am.
Excellent, my sweetie. Okay, so it's a bit of a roundabout, but those of you who are saying that I'm lost, I need you guys to tell me a little bit, where did I lose you? Yes, Atumila says they're all corresponding. Yes, you're correct. Now, there's a bit of a fight about whether we call it corresponding or whether we call it equal. According to the definition of a parallelogram or a quadrilateral, they would be equal, but because we're still proving it, we can call them corresponding. Okay. Good. Yes, good. Now Lifek says that angle B will be equal to angle D because of the opposite angles of a quadrilateral are equal. Now we can actually say that. We can actually say that now. Because of CPCTC, we can say that. We can say now that angle B is going to be equal to angle D because of the opposite angles of, in this case, it's going to be of a quadrilateral, of a quad. But that particular rule that Lihle has said is a rule that applies to parallelograms. So once we've said that, we can then make the conclusion. Therefore, ABCD is a parallelogram. Okay, if I've lost you, I need you guys to answer or to ask me a pointed question, because I'm about to move to the midpoint theorem and I don't want to leave you behind. Okay. All right, if you're with me, can I move on? If not, please make sure you write a detailed question in the chat so I don't leave you behind. All right. Okay, I think we all just need to stand up, do a bit of a stretch, take a deep breath. Ooh, okay. We're all gonna be okay. Junior's like, move on. I can't do this anymore, ma'am. Please, let's move on. Okay, so let's just like, there's no time to stretch. True. All right, let's talk about the midpoint theorem. Mateo's like, I need more than a stretch. I need a holiday. Yes, Tembelish is actually doing. All right, let's talk about the midpoint theorem. Now, the midpoint theorem is going to be so much nicer for the rest of you because it's a lot easier than it is to prove quadrilaterals. Okay, Kama, do we have a question, my sweetie?
Yes, girl.
Yes.
Yo. This triangle. Anyways, I'm so sorry. So like, seeing as like, you know, it's gonna be like the long weekend and everything, like we won't be at school for like Thursday and, you know, and Monday as well, maybe not. Do we have Watobe on Monday?
Yes, we do.
Yay!
I will be there. I'll be there and I'll be able to get all your energy. All of your energy because you wouldn't have gone to school. So I will be here. Okay.
I was low-key kind of hoping we wouldn't. I'm
sorry. I'm sorry. I'm very sorry.
Guys.
Lucky for us, Watobe is actually optional. So you can be like, nah, I'm taking a break. Hey, this woman is cutting. And then you can always go and rewatch. Okay. Oh, I'm so sorry, Ntangedi. Okay, I'm going to explain Puseletso. Okay, I'm about to explain. Ashlone, I know you may have a question for me, my sweetie. I'm gonna ask you to just hold on for me, just so I can explain, and then I'll get back to you, okay? All right, okay, so the midpoint theorem sounds complicated, but it's not, guys. It's not at all. It says here, the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half of the length of the third side. Okay, so here's what they're actually saying. They're saying that I have a triangle ABC. Okay, I have a triangle ABC. And then I decide to draw a line. And I take this side of AB. I'm sorry, Mateo. I take the side AB and I start my line right in the middle. Okay. And immediately, if I start this line in the middle, that automatically tells me that BD is going to equal to AD because I've cut AB in half. Okay, I'm cutting it in half. And then I decide to draw the line to the other side of my triangle. But I make sure that I also cut this triangle in half, or this side of my triangle in half. I also cut this side in half, which means that this side will also be equal to that side. AE will also be equal to EC. This is all that this is saying. It's saying if a line segment joining the midpoint of any two sides, this is my one side and this is my other side. And this line segment in between here is joining them from the middle of each of them. I'm taking the middle of this one and the middle of that one. What that automatically means is that this line DE is going to be parallel to this line. Okay, automatically, if it cuts the middle of both of those other lines, it's going to be parallel to the third side. And on top of that, if this side is equal to, say, let's say maybe 2 centimeters. If this side over here is equal to 2 centimeters, this side over here is automatically 4 centimeters. If this side over here is 5 centimeters, the long side over here is automatically 10 centimeters. Okay, that is what the midpoint theorem says. It says, if I give you a triangle and there's a line right down the middle and it's cutting the other two sides right down the middle, we can automatically say that this line is parallel to the third one, and that if this is x, this is going to be 2x. That's what the midpoint theorem says. So I know it sounds complicated, not at all. That's all that it's saying. Okay, Ashlon, I'm going to take your question very quickly, my sweetie. Okay, when you're ready. All right. In the meantime, we're going to have a look at this. Oh, I forgot to explain that part. Okay, yes, Ashlon. Hello.
Oh, sorry, ma'am. So, ma'am, if you want the recordings of other work, let's say, for example, trigonometry, how do you get it?
On the website. So log in with your details on the website and look underneath today's lesson. Trigonometry will come up. Okay.
Okay, ma'am. Thank you.
All right, my sweetie. All right, excellent. Okay, Tangani's like, I saw that question. Yes, Hama. So if it's connected, it's parallel, but only if the line that we have in the middle cuts the other two lines in half. Okay, only if it cuts the other two in half. Now, as soon as these two lines are parallel, guys, what kind of angles do we need to start thinking of? What other types of angles do we need to start thinking of? We see parallel lines. What must we think of? Good, Mateo. Alternate angles. What other kind of angles do we get? Alternate angles. And alternate angles, remember, they make the S, the N or the Z. Opposite angles, good. Corresponding angles, that's correct. Co-interior angles, excellent. So remember, co-interior is these, that's alternate. And then the F that we're looking for in fun, that is our corresponding angles. So look at what shape have I drawn here. It's upside down, guys. The shape that I've drawn over here upside down is that's it, Junior. You're seeing it. Good, Eunice. It's an upside down F. So that tells me that this angle over here is equal to which angle, guys? Angle D over here is equal to angle B. Good. It's equal to angle B because of the F. So angle D, or D1, we'll call it D1 and we'll call this one D2, is equal to angle B. I'm going to go to the other side and I'm going to do the exact same thing. I'm going to draw an F, but in the other direction. What does this tell me about angle E1? Which angle is it equal to? Good, it's equal to angle C. All right, so you guys are with me in that we're going to be using corresponding angles, and we're going to be using the midpoint theorem and corresponding angles, and we're going to be using all of these things together. They're going to be working together. Okay, yes, Kama.
Sorry, ma'am. Doesn't this only work when they're like both parallel? So like you'd say that angle D1. Wait, am I looking at this wrong? Oh my God. So
no, you're 100%. You're correct, my sweetie. Remember that the midpoint theorem tells us that if DE cuts these other two in the middle, it's automatically parallel to BC.
Okay. Oh.
So that's where we're getting the idea of the parallel from. Okay. So the midpoint theorem tells us that they're parallel, and then we use that to equate the angles.
So ma'am, D1 would be parallel to E2.
No. The lines would be parallel. So DE is
No, ma'am,
parallel
sorry,
to
not parallel, but like would be equal to E2, sorry.
No. Remember, the only comparison we can make is in between the two parallel lines. This one and this one, they create an
Okay.
F, and the F would be
Okay.
the corresponding angles.
So you'd say B is equal to D1.
That's it. And on this other side,
You would say C is equal to E1.
that's it. That's what I'm looking for. You got it. Awesome.
Perfect.
All right, let's look at our first example quickly. All right, it says here, the figure below shows a large triangle with vertices A, B, and D, and a smaller triangle with vertices C, D, and E. Point C, now they're telling us that point C is the midpoint of BD. What does this automatically tell me about C or DC and CB? What does that tell me? If it's the midpoint, what can we say, guys? Huh? Not parallel. What does it tell me about DC and BC? Yes, Abu. Or Tabo. Yes, Dumelo, that's it. That they are Tabo.
C is gonna be equal because of corresponding angles.
Hold on. What does this tell me about DC and CB? That they are?
DC and
DC, the length of DC and the length of CB. That they are?
equal. No.
Equal. Good. They're equal because of the midpoint. Right. Same here. They say that E is the midpoint of AD. What does that tell me about DE and EA, Tabo?
Can you please repeat?
If E is the midpoint of AD, what does that tell me about DE and EA?
They are also gonna be equal.
Good, they're gonna be equal. Good. These two are gonna be equal. So according to the midpoint theorem, what do we then know? What can we write down here? If these two are equal, what does that tell me about my third sides? Not that they are equal. What does that tell me about my third sides, guys?
Corresponding.
Not corresponding. Yes, Kanyisile. They're good. They are parallel. So this automatically tells me that side AB is parallel to side CE. And the reason for this is the midpoint theorem. Okay, midpoint theorem. Okay, they are parallel. And then only after we make that assumption, then we can say, what is the angle of C? What is the angle of C, guys? What is C going to be equal to? That's it, Eunice. That's it. C is then going to be equal to, or in this case, DCE. DCE will be equal to 91 degrees because of corresponding angles. And then we need to name which sides are actually parallel when we do that. Okay, we have to go AB is parallel to CE. Okay, let's try that again, because I feel like it gets a little bit messy as we go along. Okay, we're not going to prove similarity now. I just want us to get a hang of what's happening. All right, let's read the question over here. Okay, the question says, oh, Balisa, I'm sorry, my sweetie. All right, it says, the figure below shows a large triangle with vertices G, H, and K, and a smaller triangle with vertices J, K, and L. Okay, now it says point J is the midpoint of HK. So I know we're all in agreement, okay, that means that HJ and JK are equal. And it says that point L is the midpoint of G gate. Tiamo, I'm going to go back for you in just a little bit. And then it says point L is the midpoint of GK. That automatically tells us that this and this are equal. Does anybody want to unmute and tell me what this tells us? Okay, anybody want to unmute and tell me what does this say? What does this actually tell us? KG, right? What does this tell us? Good, Liche, what are you getting at? What are you getting at? Yes, Sipe, what does this information then tell us?
Hello, ma'am.
Hello, Masudi. What does this tell us?
So this tells us that side JL is parallel to HG.
Beautiful. That's what I was hoping to hear. JL is parallel to HG. Don't go away. Tell me why. Why can we say that? What is our reason for that? What's the name of the thing that we're doing?
Midpoint theorem.
Yes, good. The midpoint theorem. You're correct. Don't doubt yourself. It's the midpoint theorem. Okay. So what does that then tell us about this angle KJL? KJL is equal to?
Pardon, ma'am. Please repeat.
What is the size of KJL? What is the size of this angle J?
Oh, it's 60.
Good. KJL is 60 degrees. Beautiful. And my reason?
Corresponding.
Good. Corresponding angles. And then I can then say that JL is parallel to HG. Just wow. Beautiful stuff. Amazing stuff. You're a whole rock star. Well done, CP.
Thank you.
Awesome. Okay, are we getting the idea of what's happening? It's so much easier than it looks. Hey? Oh, Nolwazi is like, no, ma'am. Let's all know, my sweetie. Don't be like that. All right. Somebody asked to take a screenshot of this first question, and I don't mind that at all. Go ahead and take a screenshot. Okay. Now we just Unati is like, ma'am, one day I'll meet the person that created the subject. And I'll have a stern word with him. This person needs a stern talking to. All right. Okay, guys. Teacher Nels is going to run the pace poll for us. Okay, it's not quiz day in Tanganyika. Quiz day is Wednesday. That's it. You know what I mean? Palisa's like, life is like geometry. You can never assume that anything is true unless you've proved it, right? It's so much easier than it looks. He is dead, Michael, by the way. He's dead. It was not Gandhi. It was most definitely not Gandhi. All right, guys, it's been so fun hanging out. I know some lessons are harder than others. For those of you who just joined us, I encourage you to please go have a look at our previous lessons on the website, because they will help you understand a little bit more about what we are doing. Okay. Oh, can I please go back to the last one? Absolutely, my sweetie. There you go, Stacy. It's not Mahatma Gandhi. It's definitely not. All right. Okay. Mahatma. All right. Bye-bye, everybody. I'm going to see you guys again.